Alright guys, this next video we're actually going to look at two objectives together. We're going to look at temperature regulation via our skin, and we're also going to look at the color of our skin. And so in terms of temperature regulation, there's going to be some direct workings with the sympathetic nervous system. The sympathetic nervous system is kind of what helps us deal with stress. But the skin is going to help regulate body temperature in two main ways. And these are both going to be kind of negative feedback mechanisms that allow us to keep our temperature within a certain small range. And so when we get hot, we're going to see some changes that occur, and then we're going to go back to normal. And then when we get cold, same thing will happen. And so that's what makes them a negative feedback loop, is they kind of turn on and turn off as needed. Now we're going to see activity in the sweat glands. That's going to help us cool down when we need to. We're also going to see a change in the amount of blood flow through the skin, and that can help us both cool down or warm up. And so sweating is going to be one major way. Of course, this is going to involve those sweat glands that we call the eccrine sweat glands. And so the nervous system is constantly monitoring for temperature changes. And so when the body becomes excessively warm, it'll stimulate those sweat glands to produce large amounts of sweat. Those eccrine sweat glands are often releasing sweat even when we don't realize it. But of course, when you are active or the body is warming up and those muscles are generating a lot of heat and that body is getting hotter, it's going to trigger a greater amount of sweat production. And so the reason this cools us down is because when the sweat evaporates from the surface of our skin, that heat kind of dissipates and kind of goes with that evaporated water, and so it makes the skin begin to feel cooler. And so it kind of helps get that heat away from our bodies. And so the faster it evaporates, the cooler the skin feels. And if you've ever worked out really hard, and then you're sweating a whole lot, and then a lot of times when you cool down, you actually get cold because so much heat is being lost that it makes you feel pretty cool. And then we can also monitor temperature or affect temperature through blood flow. And so once again, when the body gets warm, it causes the blood vessels to dilate. And so a lot of that excess heat that is carried in the blood can be eliminated through the skin. And so, when you do get really hot, a lot of times your face especially will become red, or areas of your body will kind of get a little pinker. If you have a fair complexion like I do, I turn really, really red when I'm working out or I get really hot. I look like I'm about to pass out. But the skin will become very red. And normally if you are fairer skinned, you will see that redness. It's a lot more obvious in someone who has a lighter color skin. And it's just because you have increased blood flow to the area, and that's going to help dissipate some of that heat as well. Now the opposite is going to happen when you get cold. And so when the body temperatures drop, those arterioles are going to constrict. And this is about conserving heat and ensuring that our major organs are going to stay the right temperature. So you may notice that when you get cold, some of the coldest areas are going to be like your fingertips, your toes, and then the tip of your nose. And that's because blood flow is essentially kind of like being cut off to those external areas. We want to make sure that those internal organs are staying plenty warm. They're a lot more important than our fingertips and our nose. But what can happen though is if you are too cold for too long, and those body parts that they're not receiving oxygen like they need to, they can actually freeze, and that can lead to frostbite and sometimes removal of those areas. But normally if you see frostbite, it's going to be the tips of the fingers, the nose, and the toes. And then honestly, just your blood flow in general can affect your temperature. I'm always cold, and one of the reasons why is I don't have great blood flow. And when I get chilly, my fingers and my toes will kind of start to look bluish or purple because that blood flow is being reduced anytime I get cold. So anytime we want to release heat, we're going to have the dilation of our blood vessels to help dissipate some of that heat from our skin. And anytime we want to warm up, those blood vessels are going to constrict to help conserve heat in our body trunk. And so the faster evaporation occurs, the cooler your skin will be. I think there was a typo on the actual question sheet, so you may just want to change those answer choices to warmer and cooler. And then we're also going to take a look at skin color. And so there are several factors that can affect the color of your skin. It's mostly going to be your pigments, but the blood circulation can affect the color of your skin, as well as the thickness of that superficial layer of the epidermis, the stratum corneum. And so the skin color is influenced by many pigments. The main pigment is going to be melanin. It's going to be the pigment that's produced by those melanocytes in the stratum basale. There's some other pigments like keratin or carotene, and carotene is actually a yellowish orange pigment. There's a lot of it in carrots, but it's also going to be a source of retinol or vitamin A. And then hemoglobin is a pigment that carries blood. It's a red pigment. It's in our red blood cells, and it carries the oxygen. In fact, it helps our red blood cells carry a lot of oxygen. It's a protein that you'll find in your blood. And so we're mostly going to focus on melanin because it is the main pigment. And so those melanocytes that are in the stratum basale, what will happen is they'll produce melanin, and they're going to transfer it to those keratinocytes that are above them in the upper layers. And so there's two major forms of melanin. You have eumelanin, and that prefix U means true. This is what's going to give your skin the brownish or the darker colors. There is one called pheomelanin, and that's what gives it the reddish color. Same thing for your hair. And so the variation in skin color has to do with how much melanin you have and what type of melanin you have. And that's pretty much just determined by your genetics in terms of your basic hair color, your skin color. All of those things are genetically determined. You can affect the color of your skin by light exposure, and we'll see why here in a minute. And then hormones can play a role in that as well. And so in general, the more melanin you have, the darker your skin is going to be. So melanin can also accumulate in different areas, and that's what can lead to freckles and moles. A lot of times that's genetically predetermined too, whether or not you have those collections of melanin. Freckles really aren't anything to worry about. They're pretty safe. They're typically going to be on the face or the arms, and you'll see more freckles when you are in the sun more. It's one of those things that get passed down from your parents. Not everybody's skin will freckle. And then moles are just larger masses of melanocytes, and so these are the ones that could possibly become malignant melanoma, so you do want to monitor them and make sure that they're not changing or becoming irregular. Now, the reason sunlight is going to affect our skin color is because melanin is actually a pigment that helps protect us. And so when we are exposed to UV rays, it causes the melanin to be made and stored up in those keratinocytes. And so what the sun does is it stimulates those keratinocytes to secrete chemicals, and then those chemicals are going to stimulate the melanocytes to secrete melanin because there's some protective qualities. So what the melanin will do is when it accumulates, it kind of covers the nucleus of those keratinocytes, and so it protects the DNA of those epidermal cells. It's all about protecting it from that UV radiation. Now, it could lead to the breakdown of folic acid, which is not great though. And then what will happen is that as that melanin accumulates, it causes the skin to darken, and that's what gives you a tan. Is that exposure to sun equals more melanin production, and more melanin production helps to protect your skin, but it also makes your skin darker. Now, you don't want to get too much because too much melanin could affect the production of that vitamin D, so we don't want to get too tan. Plus, it's harmful to be constantly exposed to those UV radiation rays. Even if the melanin protects us, there's going to be a certain extent. Remember that they can become mutated by radiation as well, so we don't want too much sun exposure. Now, the tan is going to be temporary though. It usually takes about 10 days after initial exposure for that melanin synthesis to reach its peak. And that's why if you have fair skin, a lot of times before you tan, you will actually burn because it takes a little while for that melanin to kick in there. And then the tanning isn't permanent either because those melanosomes, the little vesicles that are carrying that melanin to those keratinocytes, they don't stick around. They're temporary. And then eventually those keratinocytes that were darker and had more melanin, we know that we're constantly replacing our skin cells, so they're going to slough off as well. So eventually that tan is going to go away. Now, in terms of the other pigments, the carotene, there's three types. There's alpha, beta, and gamma. The beta one is the one that contributes to retinol production or vitamin A in your skin. And so really the main way this is going to affect your skin color is if you eat a large amount. So if you eat a lot of vegetables that contain the carotene, it could be deposited in your epidermis and some of your fat cells, and that could actually lead to an orangey color in your skin. And then the hemoglobin is also important because it's the red pigment in your blood. It actually allows our red blood cells to carry lots and lots of oxygen. But the blood flow to your skin is going to kind of naturally give it some color as well. So if you have too much blood flow to the skin, it could cause redness. If you have decreased blood flow, like when you go into shock and that blood kind of leaves the surface, literally people get very, very pale and almost colorless. And if you have too much blood loss and the oxygen is not reaching the skin, you could have cyanosis. What happens is the blood is not well oxygenated. It's a darker red, and then through the skin it kind of has a blue appearance. So, you know, the bluish color means you aren't getting enough oxygen to those areas of the body. So depending on your blood, it can affect the color of your skin as well. You can have redness, you could be pale, or you could actually have a bluish color. And then in coordination with skin color, there is a genetic disorder known as albinism. And it is genetic, it's an inherited trait. And there's different types of albinism. But for the most part, it affects the color of the skin, hair, and eyes. And it's because a person with albinism is not producing melanin in the same way. We'll look at the mutation here in just a moment. But what will happen is, without the melanin, people with albinism, they have very light skin, very light hair. A lot of times it's almost white. And then their eyes are either a very light color or sometimes they appear pink because what you're seeing are the blood vessels. The pigment's not put in there, and so you see the blood vessels behind. Now, the biggest issue with people with albinism is they don't have a lot of protection from those UV rays because they don't have the melanin, or they don't have not nearly enough of it. And so they're very sensitive to light, and they're much more likely to have issues with, you know, skin exposure to the sun, lots of protection. They may also have vision problems because there's several things that affect the eyes and how they see. A lot of times there's some like muscle movement that other people don't have, or they may have issues detecting because they don't have some of those pigments in their eyes. And then in terms of what causes it, it is a genetic disorder, but it's due to a mutation in a gene that makes the enzyme tyrosinase, and there's a amino acid called tyrosine, and tyrosine is going to be converted into melanin via the enzyme tyrosinase. And so if this particular enzyme is not made, then the melanin cannot be produced, and so that can lead to albinism. All right, so a mutation in which enzyme can result in albinism? That would be D. Which of the following pigments is made in the skin? That would be our melanin. Carotene would come from eating plants that contain lots of carotenes, and hemoglobin is going to be a protein in our blood. Vitamin D is not one of our pigments. And then which of the following is a bluish coloration? That would be cyanosis. This one right here leads to redness. I don't know how to say that. I don't know. I'm not even going to try. And then shock leads to paleness, and albinism leads to very, very pale or almost white in color. And that wraps up those objectives.